Sometimes we will be asked some more complex questions, just asking you to evaluate something, but maybe there's two different trig functions. So, for instance, here, the inverse tangent of the tangent of pi over 6, or the inverse sine of the sine of 5 pi over 6. And sometimes the mistake that we make is a lot of times people will say, well, oh, inverse cosine and cosine, this must equal pi over 3. But you have to be careful with that, because if you take a look at something like number 20, if we were to take the inverse sine of the sine of 5 pi over 6, that would be the same thing as taking the inverse sine of, and if we take the sine of 5 pi over 6, we know that that's going to be 1/2. But then evaluating the inverse sine of 1/2, I know that the inverse sine has a range from negative pi over 2 to positive pi over 2, or negative 90 degrees to positive 90 degrees, which means this is going to give me an angle that's in that range. And 5 pi over 6 is not in that range. Yes, it has a sine of 1/2, but evaluating this inverse sine is not going to give us that. So the inverse sine of 1/2, meaning an angle within this range that has a sine of 1/2, would be pi over 6. So you need to be careful when you're doing something like this. I'll do another one. The inverse tangent of the tangent of 2 pi over 3 means I'm taking the inverse tangent of, well, the tangent of 2 pi over 3, since it's in the second quadrant, is going to be negative, and anything with a denominator of 3 is going to have the square root of 3 be the tangent, either positive or negative. So the inverse tangent of negative root 3 means what angle has a tangent of negative root 3, but again, even tangent uses a different range. It's going to be in parentheses, but negative pi over 2 to pi over 2. So which of these angles would actually have that? It would actually be something with a denominator of 3, but it's going to be negative pi over 3 because it's going to be in the fourth quadrant. So again, you can't just say, oh, these cancel, because that's incorrect. You might have some situations like this where maybe the inverse trig function is in the parentheses and then the typical, your regular trig function is outside. So for instance, on something like this, you would say the cosine of the inverse sine of root 3 over 2. Well, the inverse sine has a range from negative pi over 2 to positive pi over 2. So what angle has a sine of root 3 over 2? That's the y coordinate, and so that's going to be pi over 3. So then what is the cosine of pi over 3? That's going to be 1/2. The last thing I want to show you is something like this, where these look very similar to what we did, but if you have the tangent of the inverse sine of 2/3, this is one situation where I'm not sure what angle has a sine of 2/3. So we're going to have to treat this a little bit differently. So the inverse sine of 2/3, we know is going to equal an angle. I don't know what that angle measurement is on the unit circle in radians or in degrees. So since it's unknown, maybe I'll call it theta. So the inverse sine of 2/3, we're going to say is theta. It's some angle. I'm not sure what it is. So since I just called the inverse sine of 2/3 theta, I could actually rewrite this statement up here as the tangent of theta, since the inverse sine of 2/3 is theta. So keep that in mind. We're going to come back to that in a minute. But because I know the inverse sine of 2/3 equals theta, this is the same thing as saying the sine of theta equals 2/3. And we actually did problems like this in the first unit, where I would give you something like the sine of theta equals 2/3, and I want to know what is the tangent of theta. And typically how we would solve this is using a right triangle. So if I have a right triangle, and let's say I put theta in this acute angle, it could be in either one, but it's going to impact your picture. If theta is here, the opposite side is 2 and the hypotenuse is 3. If I can figure out what this side is, then I can figure out the tangent of theta because it would be opposite over adjacent. So let's use the Pythagorean theorem. 2 squared plus, let's call it this side is x. It would say plus x squared equals 3 squared. So 4 plus x squared equals 9. So x squared equals 5. And therefore that side length is the square root of 5. So then the tangent of theta, which again, because the inverse sine of 2/3 we said was theta, we could rewrite this original problem as the tangent of theta. It's equal to opposite over adjacent, so that's going to be 2 over root 5, which we would want to rationalize by multiplying by root 5 on top and on bottom to get 2 root 5 over 5. We'll do one more example. the cosine of the inverse tangent of 5. So again, working from the innermost, if we know that the inverse tangent of 5 equals theta, then that means that the tangent of theta equals 5, or you could think of that as 5 over 1. We would draw the picture of a right triangle. If theta is here, tangent is 5 over 1, so opposite over adjacent. We need to figure out what is this hypotenuse, because since the inverse tangent of 5 is theta, the original problem is actually asking you for the cosine of theta. So we need that hypotenuse. So 1 squared plus 5 squared equals c squared. 25 plus 1 is 26. So therefore, that hypotenuse is the square root of 26. Again, if you could simplify a radical, you always want to. In this case, it does not. So the cosine is going to be adjacent over hypotenuse, so 1 over the square root of 26. If we rationalize by multiplying by root 26 on top and on bottom, we get the square root of 26 over 26.